Bridges, section 6.7, applications and variation. So in this section, these are all application problems, things that apply our learning on these rational functions. So let's go ahead and start. So you and a friend drive to different colleges, 380 miles and 400 miles away, respectively, in the same amount of time. Your friend's average speed is 3 miles per hour faster than yours. How fast is each average speed? Of course, feel free to pause this video if you need more time to write. So the thing we have to understand here is that distance is equal to your average speed or your rate times time. And so since the two amounts of time are the same, I know that T1 equals T2, and distance 1 would equal rate 1 times time 1, and distance 2 would equal rate 2 times time 2. Notice that I can solve for T, so that would mean that distance 1 divided by rate 1 equals distance 2 divided by rate 2. Now here's the key. I know the two distances. 380 miles and 400 miles. Let's let our rate be x. Friend's rate is 3 miles per hour faster. So whatever our rate is plus 3. Well, at this point, you can cross multiply to solve this equation. So when we cross multiply, we're going to end up with 380 times x plus 3 equals 400x. If I distribute, this is 380x plus 1140 equals 400x. I can subtract 380x from both sides. So I'd get 20x equals, 20x equals 1140. And if I divide both sides by 20, I get x equals 57. So that 57 represents our average speed. And our friend's average speed is just that plus 3, which would be 60 miles per hour. Cold water takes 8 minutes to fill a laundry tub. It takes 5 minutes for hot and cold together because you're getting water from two different sources, so it's going to fill faster. They're working together. How fast would the hot water fill the tub alone? Well, what you have to understand from this is that the rate at which the cold water fills the tub plus the rate at which the hot water fills the tub is equal to the rate of the cold and the hot together. So if it takes 8 minutes for the cold to fill the laundry tub, how much of the tub gets filled every minute? So if it takes 8 minutes, it stands to reason that 1/8 of the tub would get filled every minute. So this would be 1/8 plus, I don't know how long the hot water takes, so it's going to be 1/T. And then the rate at which the cold and the hot together fills would be 1/5 of a tub per minute. So here we have to multiply by the common denominator to clear the fraction. So the common denominator between 8t and 5 would be 40t. So I'm going to take 1/8 times 40t plus 1/T times 40t equals 1/5 times 40t. 8 goes into 45 times, so that's 5t, plus t cancels, 1 times 40 is 40, equals 8t. I can subtract 5t. So 40 equals 3t. Divide by 3. T equals 40 over 3, which is a perfectly good mathematic answer. However, nobody's going to run around saying, oh, the hot water takes 40 over 3 minutes to fill the tub. So this is the same thing as 13 1/3 minutes, or 13 minutes and 20 seconds. As 3 goes into 40 13 times with 1 left over. Cost benefit. So utility company burns coal. The cost C of removing P% of pollutants from the smokestack emissions is given by this equation right here, where P is between 0 and 100. Well, that makes sense because you can't remove less than 0% of the pollutants. And you're never going to be able to remove 100% of the pollutants because, I mean, let's be real, burning coal is dirty. So, what percent P can be removed for $420,000? Well, this right here is a cost. So that can be plugged into C. And then we can solve for P. So, $420,000, guess I don't need a dollar sign there, equals, that's weird, equals 80,000 P over 100 minus P. I can make this over 1 and then we can cross multiply it. So 420,000 times 100 minus P equals 1 times 80,000 P. In other words, 42 million minus 420,000 P equals 80,000 P. I can add 420,000 P to both sides. And I get 42 million equals 500,000 P. And then I have to divide by 500,000. So P happens to be equal to 84. So that'd be 84% of the pollutants in the smokestack can be removed for $420,000. Okay. The next thing I'd like to talk about is what's called direct variation. So direct variation means that y is a linear function of x, or y equals k times x. This k here is the constant of proportionality. And so whenever we say something like this, we say y varies directly as x, or y is directly proportional to x. So if you see either of these things right here, that wasn't supposed to happen. There it is. Anyway, if you see either of those things there, you're supposed to understand that it's going to give you this equation right here. total revenue R is directly proportional to the number of tickets sold, X. When 10,000 tickets sell, revenue is $142,500. How much is revenue for 12,000 tickets? Remember, if you have to pause this to write, that's perfectly fine. All right, so it says revenue R is directly proportional to the number of tickets sold, X. So R is directly proportional to X. So that means I set this up as R equals K times X. You have to be able to read that and understand that this is the equation you have to set up. Then all I have to do is plug in, and once I plug in, I can solve for the constant of proportionality, K. So in 10,000 tickets, so 10,000, that's the number of tickets, and the number of tickets is X. So this would be K times 10,000. And the revenue is $142,500. We can divide by 10,000. And I get 14.25 equals K. Incidentally, what do you suppose that represents? That is the price of each ticket. So now I have an equation that says R equals 14.25x. So then I plug in 12,000 for x. And that gives me my revenue, which is $171,000. I don't know if you've seen this in physics, but it comes from physics. It's called Hooke's law. The distance a spring is stretched, or compressed for that matter, varies directly as the force on the spring. So let's say I've got a spring. And let's say that I take that same spring and I attach a 20-pound weight to it. That 20-pound weight stretches the spring 5 inches. If I took the same spring and attached a 30-pound weight to it, how far would the string stretch? How far would the spring stretch? Well, the distance, we can call that d. Varies directly as the force. We can call that F. So if d varies directly as F, that means that d equals K times F. Five inches is equal to K times the force, and the force in this case is 20 pounds. So therefore, K would be 1/4. So the distance is equal to 1/4 of the force. So if I plug in 30 pounds for the force, I would get 15/2, which would be 7.5 inches.